And we'll go on to the next question. So this is question number 10. All right. Okay. So here we're asked, increasing the mass attached to a spring will increase the angular frequency of its vibration. So we have some mass, so there's a wall, and we have a mass over here, and it's attached by some spring like so. And we're wondering what happens when we increase mass. If we increase mass, what will be the effect on the angular frequency? So what happens to angular frequency? Put a question mark. Let's go through with the junior tutor answers. So mass M attached to a spring. Spring constant K is hanging vertically. So we're saying it's hanging vertically. So here doesn't really state, is stretched to a vertical distance x and released. The hanging mass starts oscillating. The frequency is as follows, and the angular frequency is as follows. Also, by substituting the values of k and m from the equation, thus the angular frequency does not depend on the mass of the object, hence increasing the mass will not affect the angular frequency. So if it's hanging vertically here, this is true based on the free body diagram, and we are able to substitute in. But if we're thinking about it, if it looks like this equation down here would not necessarily apply. This equation applies more to a pendulum because it's swinging back and forth, and the force of gravity is affecting it. In our diagram here, the force of gravity does not affect the x direction over here. But we can even still look at this equation. So the equation for the angular frequency is the spring constant divided by the mass. So even if we were to increase mass, since mass is in the denominator, so if we were to increase this, the entire, so all of this will decrease. So W will go down. So if it was, so here we're saying increasing the mass attached to the spring will increase the angular frequency. So this is false. So we know that the answer is false. If it was hanging vertically, the junior tutor here describes that you can substitute this based on the free body diagram, and you will get the following. And because length here, so M, so G, K, X. So X is substituted here to get length. So you'll end up with this equation, and you'll have that mass does not affect the oscillation. So in both scenarios here, usually when I think about this question, I look at it in this diagram. So the question here doesn't really specify, but if we had this kind of diagram, we know if we increase the mass here, the angular frequency here would decrease. And if it was vertically hanging, it would be the same thing. So we would never, this statement in any scenario would always be false. So in the scenario presented by the junior tutor and in the scenario that we just went through right here. So correct answer. Great job. And we'll mark this solution as correct.